A very good evening, everyone. So welcome to our interesting session on side distance. Welcome, everyone. So guys, welcome to the India's most comprehensive live learning platform, that is BYJU'S Exam Prep. And in the today's session, we are going to start our series on transportation and engineering. And today we are going to discuss side distance. Specifically, we are going to be discussing all the side distance, not just stopping side distance. Okay, so we are going to be discussing stopping side distance, overtaking side distance, and intermediate side distance. So we are going to be discussing all these topics in the today's session. All your doubts are going to be referred in the today's session, guys. So quickly comment in the chat section and let me know all those who have joined, so we can start the session really quick. So we have a lot to discuss, we have a lot to learn today. So we'll start soon enough. Very good evening. Very good evening. Good evening, Sanjeev. Welcome, everyone. So we have a lot to discuss today, guys. So quickly tell me, everyone, all those who have joined, comment in the chat section if the audio and video is clear to all. Right? So let us start. So before starting with the session, guys, do subscribe to the channel, share the session as much as you can. Okay, and click on the like button, everyone. So guys, my name is Rohan Goyal, and I have a master's degree in structural engineering from IISc Bangalore. I have scored an All India rank of 96 in GATE 2020, and these are the subjects that I teach at BYJU'S Exam Prep, everyone. So the PDF of the today's session is also going to be provided to you at my Telegram channel over here. Along with this, okay, let me tell you one new thing that I am starting on my channel, on my Telegram channel. I will be providing you homework questions. So you can also join the Telegram channel through this link over here. And in this Telegram channel, I am going to be starting a new thing, that is, I am going to be providing you assignments. And one very interesting thing that is going to happen on this channel is Zoom sessions. So if you want to be part of these Zoom sessions in which I am going to be taking all your doubts, okay, in which I will be taking all your doubts, you just have to comment in the comment section on my Telegram group that you have a doubt which you want to get resolved through Zoom. So you can just write doubt, Zoom doubt, or doubt Zoom. Okay, so I will be registered, I will be taking your details, and I will be conducting a Zoom session on my Telegram channel. So as soon as I get few number of students, I will start a Zoom session. Okay, I will take a Zoom session for all of you guys. All right, so this is something new that I am starting on my Telegram channel. So if you want to get your doubts clarified face to face, so this is something that students are facing on the online platform. Okay, so I will be taking this initiative over here in order to solve all your doubts. Okay, and I will also be providing you an assignment for this transportation also, which you have to solve and tell me in the we are going to be solving. I am going to be giving you the solution in the group itself. All right, and Ashutosh sir is taking a very interesting session on how to ace GATE 2023. Okay, so do be a part of this session. You can register the session on 8th of May 2022, which is going to be conducted at 12:30 p.m. All right. Telegram channel not working. No, you just have to search Civil by Rohan Goyal. You can join my channel. You can search Civil by Rohan Goyal. You will find my channel. Yeah, I can also share you the link as well. Okay, let me share you the link. So in the comment section, you can see I have shared the link to my channel. You can join my channel through that link. Okay, if there is any doubt regarding your preparation, your doubts are going to be clarified in this channel over here. Okay, all right. So in the today's session, what all I am going to discuss today, let us see through this content box over here. So first of all, we are going to be starting with the stopping side distance, in which we are going to be studying PIV theory, stopping side distance without any gradient on the road. what is the effect of gradient on the stopping side distance, and what are the different types of questions which are asked from this topic. Then we are also going to be studying overtaking side distance and what is overtaking zone. After that, what is intermediate side distance, and lastly one very important note point is also going to be given to you. So do be a part of the session till the end. You are going to really have a very good insight to this particular topic itself, and it is very important for the GATE examination. A lot of questions are asked from this particular topic very frequently. Okay, one question at least is asked every year, okay, most probably. So it is a very important topic. Let us start, guys. Okay, so let us starting with the stopping side distance. What do you mean by stopping side distance? Stopping side distance is also referred to as non-passing side distance, or absolute minimum side distance, or headlight side distance. Why? See, it is the minimum side distance which is required for the driver to stop the vehicle as soon as he sees a object of a certain height. Okay, it is if you are driving a vehicle, so a certain height of an object if you see at some distance, so you require some minimum distance to apply the brake and stop the vehicle. So what is this distance which is required to stop the vehicle is referred to as stopping side distance, and these are some more names of the stopping side distance. So what is stopping side distance? The side distance available to a driver traveling on the road at a specific height. So the height of the driver I is also specified in the IRC code. What should be the height of the driver I is also specified. So the height of the driver I above the road surface is 1.2 meter. 1.2 meter is the height of the driver I. So the driver over here, who is sitting over here, is at a height of 1.2 meter, and he sees at an instance he sees an object whose height is 0.15 meter. So a object he sees over here whose height is 0.15 meter. So how much distance is required for him to stop is referred to as stopping side distance. Is it clear to all? If there is any doubt at any point, you can comment in the chat section. Now, as per IRC code, the coefficient of longitudinal friction lies in the range of 0.35 to 0.40, and the lateral friction is 0.15. Now, this longitudinal friction varies with your speed of the vehicle. Okay. So it varies with the speed of the vehicle. Now, if the speed of the vehicle, as per the IRC code, if the speed of the vehicle is less than or equal to 30 km per hour, then the friction coefficient can be taken at 0.40. If it is 40, in the range of 30 to 40, 0.38, 50, you can take 0.37, then 60, 0.36, 0.36, and lastly it can be taken as 0.35 if the speed is 80. But guys, this is only for the reference purpose. Okay, you will be provided with the friction coefficient value in your GATE examination. If it is an engineering services examination, it is possible that they may expect you to know this value. Okay, most probably they are going to give you a speed in the range of greater than 60 only, but still you can remember this table, very easy to remember, right? Now let us understand what is stopping side distance, right? Now this is a vehicle over here at some time t is equal to 0, and this is the object over here. What is the height of the object? Comment in the chat section and let me know quickly. If you remember, tell me what should be the height of the object that he should be able to see. Comment in the chat section, guys, everyone. So yes guys, tell me in the comment section, everyone. Quickly comment in the chat section, everyone. What is the height of the object? Just now I have told. Yes, very good, very good. Sanjeev, very good. It is 0.15 meters. Right. So now the stopping side distance is divided into two parts. The stopping side distance is divided into two parts. That is it is divided into two parts. That is lag distance and braking distance. Lag distance and braking distance. Now what is lag distance? See, as soon as this driver is going to see the object, a certain amount of time he will require to act. Now what is that amount of time? See, once you see the object, okay, your brain is going to perceive the object, okay. After perceiving the object, your brain will understand the situation, so he is going to do some intellection work. After intellecting, he will understand that you are going to collide that vehicle, or you are going to collide that object until and unless you do not apply a brake. So you will act upon it, you will have some emotion. So you are driving like this, you see an object, and then like you are afraid now that you are about to collide. So now you will apply the brake. That means you are now volition is now taking place. So this is referred to as PIV theory, okay, which consists of all these four processes. So you are going to stimulate, that means you are going to perceive, you are going to intellect, and emotion is going to come, and then response is going to happen, that is volition, right? And ultimately this is going to happen. So what is the time required from seeing to applying the brake is referred to as the lag time. The time required from seeing the object to applying the brake is your lag time. And as per the IRC code, this lag time is given to us as 2.5 seconds. This lag time is given to us as 2.5 seconds. Now what is this 2.5 seconds? This 2.5 seconds is 90th percentile reaction time. What do you mean by 90th percentile reaction time? 90th percentile reaction time means that 90% of the people will be able to react within 2.5 seconds. Okay, with 90% of the people will be able to react, will take either 2.5 seconds or less than 2.5 seconds. Remaining 10% are either drunk or are not aware. Okay, so we take this time as per the 90th percentile reaction time. I hope you understand this point, everyone. I hope you understand this point, everyone. Okay. Now, what will be this distance from here to here? This is your lag time. Your lag time is how much? 2.5 second. So this lag time will be equal to how much? Speed into time. So velocity into time, right? So this is your lag time, okay? This is your lag time. Now at this point you will apply your brakes. Now the brakes are applied. At this moment you have applied your brakes, and slowly now your car is going to decelerate, your car is going to slow down, and at this particular location over here, the velocity is going to become equal to 0. See, at this particular time the velocity is, say at this particular time your speed is equal to some v. At this particular time also your speed is equal to some v, and at this, from here to here, it is going to decelerate, so speed will become equal to 0. I hope it is clear to all. So what is the distance from here to here? The distance from here to here is referred to as your braking distance. So in order to find out this braking distance, we are going to use energy conservation. So kinetic energy initial minus final is equal to work done. Okay, so half mv square is your initial minus half m0 square final is equal to force into displacement. Your displacement is your this braking distance. Let us call this as S. Let us call this as S. Now what is the force that is acting on this vehicle over here? So the weight of the vehicle is W. the weight of the vehicle is W. So when you are applying the brake, friction is going to act in the opposite direction. So a frictional force is going to be there, whose value will be equal to Fw, where F is your frictional coefficient, right? So the force is Fw and the displacement is S. Any doubt up to this point, guys? Any doubt up to this point? Any doubt up to this point? Okay, clear. So this is 0. Okay, so half mv square is equal to F. Weight is equal to mg into S. So m and m cancels out. So your braking distance comes out to be equal to v square upon 2gf. Is it clear to all? Is it clear to all? So what is the total distance? V into reaction time plus v square upon 2gf. So what is your stopping side distance, everyone? What is your stopping side distance? So braking distance we have already calculated. Your braking distance is equal to v square upon 2gf. Okay. So what is your stopping side distance? Stopping side distance is equal to v into tr plus v square upon 2gf. Now let us write it over here. Stopping side distance is equal to v into tr plus v square upon 2gf. Right. So this is the first type of question where you may directly ask what is the stopping side distance. Okay. Now most of the time in your numericals the velocity will be given in kilometers per hour. Okay. Your time will be in seconds. Okay. And your distance will be in meters. So we will make this formula in our desired units. So over here this velocity is in meter per second. This is in seconds. Okay. Over here this is also in meter per second. This is meter per second square. So let us make the formula in our desired format. So velocity converted into meter per second, kilometer per hour to meter per second, it will be v divided by 3.6. You can say it yourself. Okay, that is very easy, right? Kilometer per hour to meter per second. So now this is in kilometer per hour into tr. This is no need to change tr because it is in seconds only, plus v upon 3.6 whole square divided by 2 into 9.81 f. So I have substituted the value of g also. So if you simplify this, you will get 0.278 v tr plus v square upon 254 f. So your simplified formula comes out to be this one. This is your simplified formula for stopping side distance, everyone. Any doubt to anyone? Any doubt to anyone? Is it clear to all? So it is a very easy formula. You can use this formula also, no problem. But over here, now your units are more aligned with your problem. Now your units are more aligned towards your problem. Now over here, this is in kilometer per hour. I hope it is well visible. This velocity is also in kilometer per hour. Okay. You will get your stopping side distance in meters. So now you have to straight away just put all the values in this formula over here. Okay. And guys, do like the session, everyone. Share the session as much as you can. Okay. So you are going to get the full knowledge of the side distance in this particular session itself. Overtaking side distance also we are going to study, all the provisions, and the intermediate side distance also we are going to study. Moving on. So now if suppose braking efficiency is given. Now guys, as you all might recall that your brakes tend to get loosened after a certain while, right? So you go to the mechanic and ask him to tighten the brakes because now the brakes are little loose. Okay, you do not get the full efficiency of the brake. Now in case, now that is a very practical example, well, that is a very practical thing. So you have to take that into consideration, right? So if you are assuming that the frictional factor is 0.35, now if the brakes are not 100% efficient, you will not get the full friction factor. So you have to modify it as per the braking efficiency. Your B is your braking efficiency. So if in case you are given the braking efficiency, you also have to incorporate that into the formula. Now let us write it as per our formula that we have converted. So stopping side distance will be equal to 0.278 VTR plus V square upon 254 FB. Any doubt? Any doubt to anyone? I hope it is clear to all. Quickly comment in the chat section and let me know if there is any doubt to anyone. Is it clear to everyone? Yes or no? Quick comment in the chat section to everyone. Tell me if the concept is clear to you all. Yes or no? If this much is clear to all. If this much is clear to all. Yes. Very good. Now while deriving this formula over here, now our vehicle is moving on a straight path. Now suppose if this path is inclined. Now if this path is inclined, as in this particular case over here, okay, now the weight is going to act like this. Okay, so a component of the weight is going to be in this direction, W cos theta. And one component of the weight is going to be in this direction, W sin theta. And since one component of the brake is in the opposite direction to the motion of the vehicle, one component of the weight is in the opposite direction to the motion of the vehicle. So the moment you apply the brake, don't you think that this car is going to stop in a less distance? Yes or no? So the modified formula, just by drawing the free body diagram of this car, you can calculate it very easily, comes out to be equal to, see, this is the braking distance over here. Okay, this is your braking distance. Lag distance, there will be no change. In the lag distance, there is no change. Only change will be there in the braking distance. Now, you will have to either plus minus tan theta, you have to do whatever is the inclination of the road. If it is an up gradient, this braking distance will decrease. So you have to increase the denominator. In order to decrease this value, you have to increase the denominator, and in order to increase the denominator, you have to use the plus sign, right? And if it is a down gradient like this, the distance will increase, so you have to decrease the denominator, so you will use the minus sign. I hope it is clear to you. And the same formula can also be written as V square upon 254 FB plus minus tan theta. And my friends, one very note point over here, you have to make notes. We are going to be having one numerical session which I am going to tell all the sessions which I have planned in this series. Okay, so I am also going to be providing you a separate assignment and a numerical session separately. And all those things you will be able to solve with these sessions, and these are going to cover very, very important topics for your GATE examination. If you are taking this series seriously, then you can say that you have a very good knowledge of transportation engineering. Okay, you have covered a lot of topics with this series only. So try to make notes of this subject. Okay, so I will be providing you the PDF on my Telegram group. Okay, from there you can make your notes. If you haven't studied transportation engineering, this is your chance to start with the transportation engineering, right? All right. Now, so first is your finding stopping side distance based upon your gradient. So this is your ultimate formula. Right, in which you will take braking efficiency also into account, your gradient also. So this is your braking efficiency. Your gradient. Okay, your this is your lag distance, this is your braking distance. I hope it is clear to you. The formula is crystal clear to everyone. I hope it is so, right? Now, there are some cases, right? The stopping side distance, one is your, they will ask you straight away what is stopping side distance. Next you have based upon the number of lanes. Okay. Now if it is a single lane one-way road, only one-way traffic is allowed. In that case, you only require stopping side distance. If it is a two-lane one-way, now if it is a two-lane one-way, then also you only require stopping side distance. If it is a two-lane two-way, then also no problem. I hope you are understanding. One lane one way, single lane one way is that a single lane is there and only one way traffic is allowed. Two lane one way is that you have two lanes like this and only one way traffic is allowed. Then two lane two way means you have a two lane road and two-way traffic is allowed like this, right? I hope you are able to understand. This is one, sorry, this is one, again sorry, this is one, this is two, this is third case, and this one is your single lane two-way traffic. Now see everyone, this is the point to be considered. Now suppose a car is coming from this direction and a car is coming from this direction. Okay, they are both traveling on a same lane. Okay, so this is a single lane two-way traffic is there. Now if once they see each other, how much distance will they require? Either they will require 2 times stopping side distance, because one stopping side distance will be for this one, or you can say if it is traveling at v1 velocity and this is traveling at v2's velocity, so it will require SSD1 and this will require SSD2. Okay, so this will require SSD1 and this will require SSD2. So what is the total side distance required? SSD1 plus SSD2. So in this case, if both the cars are traveling at the same speed, then 2 times stopping side distance, and if they are traveling at different speeds, then it is SSD1 plus SSD2 everyone. Is it clear to all? Is it clear to all? Okay. So with this, we are done with all the concepts of the stopping side distance. These are all the problems which are asked. All the concepts are now delivered to you. Okay, you need not study anything beyond this point. Okay, you can solve any question for the GATE examination by using this knowledge over here. And we are going to have a numerical session also separately, in which I am going to be solving all the problems, all the different types of problems which has been asked or which could be asked in this from this particular topic. Okay, and if you like the session, guys, do subscribe to the channel everyone. Click on the subscribe button and you will be notified to every session that I take, which will be on transportation series and any other subject also. We are bringing very quality sessions for you guys, which are going to be very helpful to you kickstart your preparation. Okay, now you are going to kickstart your GATE preparation everyone. Yes or no? Quickly comment in the chat section everyone. Are you ready to kickstart your preparation, guys? Are you ready to kickstart your preparation everyone? We are helping you to kickstart, guys. You may feel that, sir, from where to start, how to start, what to study, what not to study. This is what we are bringing for you to kickstart your preparation, everyone. I think this is a very easy concept that you have studied right now, and I don't think that there is anything over here which you may feel that is a difficult or which you are not able to understand. It is very crystal clear to you. It is very easy to understand, and you can solve any question which is asked from this particular topic now easily. You can now go to the GATE previous year question, try to solve all the questions after the session, and you will find the difference. Right, now starting with the overtaking side distance. Now what is overtaking side distance? If suppose a vehicle is traveling on a road. Suppose you are traveling on a road and you see a vehicle ahead of you which is traveling at a lesser speed. Now your tendency will be to overtake the vehicle and move ahead. You are not going to stay behind him the whole way, right? So you are going to overtake the vehicle. So some certain length of the road is required to be seen by you. Okay, in order to overtake, you should be able to have some visibility so that you are able to overtake. Now this distance which is required for you to see properly in order to overtake the vehicle is referred to as the overtaking side distance, right? Now let us understand what are the different components of this overtaking side distance. Let us see, you are sitting in the vehicle number A. So, and this is the vehicle number B which you want to overtake, right? And there is a vehicle number C which is also coming from the opposite direction also. So this is a two-lane, two-way road. Two-lane, two-way road. So because the vehicles are traveling in both the directions. Now what will happen over here? Suppose you are traveling at some velocity v over here. You are traveling at, let us understand, you are traveling at a velocity v over here. Now when you see the vehicle over here which is traveling at some VB speed, okay, now in order to overtake, firstly you will slow down to VB speed. You will slow down to VB speed and travel behind that particular car for a certain distance till you analyze the situation. Is there any car coming from the opposite direction? When you see that it is safe enough, so you are traveling for some distance d1 until you find that it is safe to overtake. So this is your d1 time. This is your d1 distance that you have traveled from a1 to a2 to analyze the situation and to start overtaking. Okay, at this point A2, you start to overtake. Okay, you accelerate, you start to accelerate. And you start to accelerate, and the same time there is another car C which is coming from here to here. Let us call this, let us say this is as a time t, small t, in which you are analyzing the situation. And after analyzing the situation, when you start to overtake, let us say you took total time t, capital T, in order to overtake from here to here. And in the same duration, the C1 car has reached to C2 in that same time t. Yes or no? I hope the situation is clear to all. I hope the situation is clear to you all. You are in car number A. First of all, you slow down to VB speed. Okay. You traveled for some time small t. After analyzing the situation, you started to overtake and you did all this overtaking operation in capital T time. And in the same time, this C1 car has come from here to here. So what is the total distance? D1 distance plus D2 distance and plus D3 distance. The distance traveled by C1 to C2 is also a part of overtaking side distance only. So let us see what is D1 distance. So D1 distance will be simply VB into T. What is VB? I will explain. Okay, VB is the speed of your vehicle number B, right? And if in case you do not know what is the value to be taken, that is also going to be told to you. So VB will be taken as, so what is the time T? As per IRC code, the time T is equal to 2 seconds. So 2 seconds you are going to take to analyze the situation to start your overtaking operation, right? Then your VB is your speed of the slow vehicle, which is equal to the design speed of the road, minus 4.5 if you are calculating in meters per second. And it is equal to capital V minus 16 if you are doing your calculation in kilometer per hour. I hope it is clear to you all. So now you are traveling for 2 seconds at this VB speed up to calculate the D1 distance. Okay. Then D2 will be equal to, from here, so this is in this capital T time. Okay, you have traveled this S amount, then this B amount, and then this S amount. So I will tell you what is this S, what is this B, and what is this S. So can I say B plus 2S amount? B plus 2S amount, right? I will explain one by one each and every point. What is B over here? So in this time B over here, in this B distance is the distance traveled by the vehicle number B from here to here in this capital T time. So B will be equal to VB capital T. Yes or no? Yes or no? So the B vehicle has traveled from here to here in this capital T time. So it will be VB into capital T. And what is this S? S is your space headway. So before overtaking, you are going to travel behind the slow vehicle for a certain distance, right? And when you are traveling, you will leave some minimum distance between your vehicle and that vehicle. And what is that minimum distance is referred to as the space headway. And that is given as per IRC code. The space headway, the distance between your vehicle and the next vehicle, between this your vehicle and the next vehicle is given by the IRC code as equal to 0.7 into V as your design speed, okay, into V plus 6. 6 is the length of your wheelbase. And if you, this is in meter per second, this V is in meter per second, this whole is in meters. And in the kilometer per hour, it is 0.2 capital V plus 6, where this is in kilometer per hour, and this is in meters only. Okay, where your 6 is your length of wheel base. Okay, 6 meter is your length of the wheelbase of a particular, if a car, whatever it is. Okay, so standard value of a 6 meter is taken into consideration. So this is the distance which you will maintain. This is the distance which you will maintain between your vehicle and B vehicle. Okay, and after overtaking, the same distance you will maintain between the B vehicle and your vehicle. So you have maintained the S distance over here. Okay, then you started to accelerate, and then again you have obtained a S distance over here. Is it clear to all? Yes or no, everyone? Any doubt up to this point, guys? Tell me, guys. Any doubt up to this point? Yes, everyone. Is there any doubt up to this point? Okay. One small correction. This is VB. This is also VB. Okay, this is VB over here. This is the speed of the slow vehicle. VB is the speed of the slow vehicle. Okay, this is the as per the VB speed. Okay, VB is the speed of the slow vehicle. V is the speed of the design speed of the road. V is the design speed of the road. Okay, so we will be given the design speed of the road as per the highway. For example, if it is a national highway, it is going to be 80 km per hour. If it is expressway, it is going to be 100 km per hour. Okay. Now, D3 distance is equal to, now this C vehicle is traveling at the design speed. So, the distance traveled by this C vehicle at the design speed in this T time is your T3. So, it will be V times T. So this is your D3. Okay, I hope it is clear to you all. Okay, I hope it is clear to you all. I am going to tell you further what is T value. T value we are also going to calculate. Okay, now from here what we have obtained, overtaking side distance is equal to D1 plus D2 plus D3, where D1 is equal to VBT, D2 is equal to B plus 2S, and D3 is equal to V into capital T. Okay. Now, if you see over here, the vehicle A has started to accelerate from this point to this point, and it has accelerated for time T. So the D2 distance can also be written as UT, that is VB T plus half AT square. Yes or no? UT plus half AT square can also be written like this. Yes? Yes or no? So D2 is equal to B plus 2S, which is equal to VB T plus half AT square. This B is equal to also VBT plus 2S is equal to VBT plus half AT square. So VBT cancels out. So from here your T comes out to be equal to 4S by A under root. So you are going to be given the deceleration value. Okay, retardation value will also be given to you in the question. So the time period can be calculated from here. Okay, you know what is S, you will be given A value, so you can find out T. From here T, when you find out T, you can find out D2, right? So this is your overtaking side distance, right? I hope it is clear to you. Is there any doubt to anyone up to this point? Is there any doubt to anyone up to this point, guys? Is there any doubt to anyone up to this point? Now, so you can easily calculate what is the overtaking side distance. Now this is what? Undivided highway, right? So this is an undivided road, because in this undivided road you are able to overtake over here, right? This is a 2-lane, so it is undivided, so you are able to overtake. Now what if it is a divided highway? What if it is a divided road like this? If it is a divided road over here actually it is a dual carriageway, okay? But I hope you understand the significance. This is divided, right? Suppose you have, and if you are here required to overtake, if you are here, if in a divided case you are required to overtake, so you are not concerned about this C vehicle. You are not concerned about the C vehicle because it is divided, it is traveling on the other side of the divider, and it is traveling on the other side of the divider, so we are not concerned about the C vehicle. So the overtaking side distance in this particular case will only be equal to D1 plus D2. Okay, in this particular case it will only be equal to D1 plus D2. Clear? So this is another type of problem which is asked from this particular topic. Okay, third type of the problem which is asked on the overtaking zone. In some cases the land is restricted, so you are not able to provide a good width of the width to the road. Okay, so it becomes really difficult for the vehicles to overtake. So in those cases you have to provide some particular length stretch of the road for the overtaking purpose, right? So the length of the road is provided in such a manner. So this is your overtaking zone. In this what happens is, so suppose this is the road and you are traveling in this direction. So you will see a signpost over here. You will see a signpost over here that overtaking is starting. Signpost over here that overtaking zone is starting. A signpost is going to be there that overtaking zone is starting. This signpost will be available at a distance of overtaking side distance from the overtaking zone. This is your overtaking zone, and the signpost will be provided as OSD distance from the overtaking zone. Then you will provide the overtaking zone, and over here another signpost will be there which will be telling you that the overtaking zone is about to end. Similarly, in the opposite direction also, a signpost is going to be there to tell you that the overtaking zone is starting, and signpost is going to be here to tell you that overtaking zone is ending, right? So what is the desirable length of this overtaking zone? What is the desirable and the minimum length of this overtaking zone? So the minimum length of the overtaking zone is equal to 3 times the overtaking side distance. Minimum to minimum is 3 times the overtaking side distance, and the desirable is 5 times the overtaking side distance. So this is another type of question which is asked from the overtaking side distance topic. Okay, then what is intermediate side distance? Intermediate side distance is your adverse case, where you are not at all able to provide any overtaking side distance. Okay, so in order to allow some amount of overtaking, you will provide intermediate side distance. Okay, that also in a sheer you can say you are having no choice. You have to give some space for the overtaking purpose. So intermediate side distance is provided, and this intermediate side distance is equal to 2 times the stopping side distance. Intermediate side distance is equal to 2 times your stopping side distance. So this much of side distance you will provide in order to provide some amount of the overtaking operation. So from here you can conclude that stopping side distance is the minimum, then you have the intermediate side distance, and overtaking side distance will be the maximum, right? So now the note point over here is, what is the driver's eye and what is the object eye in the different side distance? If you talk about the stopping side distance, the height of the driver is 1.2 meters and the height of the object is also 0.15 meters. In the intermediate side distance case, now the overtaking operation is taking place. In order to overtake, you have to see the other vehicle on the opposite direction. And the height of the driver's eye on the opposite direction is also 1.2 meter. So the height of the driver is also 1.2 meter and the height of the object is also 1.2 meters. And similarly for the overtaking side distance also, the height of the driver is 1.2 meter, and in our case, in the overtaking side distance case, the object is also another car on the opposite direction. So I am referring to car number C over here. This is a C number car. So the height of the driver's eye in the car number C is also 1.2 meters. I hope it is clear to you all. I hope it is a very valuable session for you all and you are able to understand what is side distance clearly in the today's session. So with this, we are going to conclude the session. Subscribe to the channel, click on the like button, okay, and stay tuned with me, and we are going to have a lot more session like this, okay. So with this, we wind up our session, guys, okay. Thank you everyone, take care. And Abhinav Negi sir is also going to take another session on soil mechanics. He is going to discuss some numericals, so you can watch that session also in today at 10 PM on our BYJU'S Exam Prep Hindi channel, okay. So thank you everyone, download our BYJU'S Exam Prep app. Take care everyone.